All right, welcome guys. This is part 2 or page 2 of lesson 1.4. So let's begin right away. Hopefully you guys looked at the last one and we kind of ended on what we're talking about combining like terms. And so we want to make sure we understood what these references are. Okay, so 17u and 25u can be combined together because they have the same variable, and that would be 42u. And remember what it represents is u could be umbrellas. Okay, we'll just use the same. So you're saying you have 17 umbrellas laid in a pile over there, and you have 25 umbrellas over here. We're going to throw them all together, and what do we get? We get 42 umbrellas. Okay, simple setup like that. All right, and this one here, this is 6t squared. Remember, I used my example of super gluing pens together. This time it could be tables, and then it'd be plus. Now this is 3t, and remember this is 1, so it'd be 3 minus 1, so it'd be 2t. And this one over here, combine like terms, right? So what you want to do is understand that these two are similar. This and this are not like the other. So this would be 4y to the third, and then it's going to be a plus 5 on the outside. But what goes in the middle? It's 2 minus 8. Okay, so that would be a negative 6y. Remember what it is? Say you have two yellow something. Who knows? I don't care. But you have something over there. You have two of them, but you need to take 8 away. So if you take 8 of them away, you're in the whole 6. Okay, it's kind of if you think about money. When we get the negative exponents and all that stuff, I start talking about money, saying if I have $2, but I have to pay somebody 8, I can pay them 2, but I still owe them 6. Well, that's a negative number if you owe somebody money. So you got to think of it like that, negative numbers. Okay. All right. Simplify these expressions as follows and go. All right. Simple enough, guys. 6n minus 4n would be 2. B 6 minus 4. B squared is all by itself, but you can combine these. 13 and 3 would be 16b. And then the other one here, this is separate. So I want you to write it in standard form, which would be, we'll talk about later, but it would be the greatest exponent first, which would be a squared. So it's negative 6a squared. And then the plus 4 is by itself over here. But you have this term, a negative 2a and a 7a, which are similar. So hopefully you guys went 7 minus 2, which would be 5a. Okay, now we're going to be talking about using and combining like terms using the distributive property. So make sure you do your multiplication first appropriately. Okay, so on this one, I want to make sure you understand is this is 2w and this is negative 6. But what we have on the outside here is making sure you guys understand. So let me block this off and then I'll undo it. Pick the colors here. Okay, so what you guys need to understand is that this is basically if I take those two numbers down, or the terms down, this is what we have left. Okay, it is a negative 6, and then it's times negative 3x plus 5w. So what you do is you make sure you distribute the negative in, right? Negative 6 times negative 3 would be positive 18x. Negative 6 times a positive 5 would be negative 30w, right? So please make sure you guys understand that setup and how you carry forward the negative in front. It's not a positive 6 that's coming out. It's a negative 6, okay? All right, and then the next thing is as you go through here, now you combine like terms. Now I'll use the associative property, and I will move these terms next to each other like this, rearrange them, and then this is going to be plus 18x minus 6x. Now the question becomes, do I have to do that? The answer is no. The other method that you may have learned would be kind of like a circle square, where you would square up the terms that look alike, and then you might take and circle those terms, the other terms that look like, just like this, right? And always carry the symbol in front of it. Notice I circled plus 18, I squared negative 30, and I squared negative 6. You combine those things together, right? So I just rearranged them on this one. So this would be negative 28w, and then it's going to be a plus 18 minus 6 is a 12. So remember how it works is if you have $18 and you go spend 6, you now have how much money in your pocket? 12 bucks, okay? Make sure you remember it just like that, all right? Then the other one here, now you can rearrange it if you don't like that with a negative like that, if that makes you feel more comfortable. All right, same thing here, right? So drop the 5y down, drop the negative 3z down, and then once I do that, I can kind of eliminate these two, and you can see what I have left, right? Negative 2, so this would be negative 4z, whoops, negative z, and then negative and a negative is a positive 12y. Now, I'm not going to, I'll do the circle square this time, so it would be like a circle this and circle that, and then you guys can kind of see what's left, where this would be a, whoops, I would like to change the color when I'm doing this. This would be a kind of a square like that, and a square like that, right? So the negatives are a pound of it. So this would be 17y, and it would be negative and a negative, adding them together. So if you go over there and you're going to go buy something for $4, and you go over there and buy something for $3, you don't magically have $7. You have spent it. So it's negative 7z. All right, the last one here, negative 4w minus 12z positive 18w minus 2z. Okay, you combine the z's together, so that's going to be negative 14z. Combine the w's, and that's a positive 14w. Okay, so there is how you combine the like terms. Okay, make sure you keep the negatives straight. Make sure you guys understand what the like terms are, and now you try. All right, the last thing here is making sure as we go through this exercise, 4w minus 10z plus 30w, and then this is going to be minus 3z. And then you would you can do the circle square method if you want, or I'll circle this one and circle that one. And then I'm not going to do the other one because that's 4 plus 30 is 34w. Negative and a negative, remember, is still, you're not changing it. It's only changes to a positive number when you multiply or divide, right? So you're combining like terms. Remember, you're going in, you spend 10, you spend 3, you spend 13. That doesn't magically all of a sudden become a different number. 6, oops, that's not a 2. All right, so this would be negative 4y minus 6z. And then this is going to be a plus 15y plus 3z. Put these two together, so the y's would go together. That's 15 minus 4 would be 11y, and this would be a negative 6, and a positive 3 is a negative 3z. All right, last one, 4w, 12x, plus 12w, and then plus 2x, right? So understand how I get here, and then go from there, right? Combine the like terms and move forward. Hopefully you guys got those answers correct. All right, last thing I want to show you guys, and I'm going to do these first two here, and then on your notes they're kind of put together, but it's identifying the parts, okay? And so what we've talked a little bit about these is making sure you guys understand what is a true statement and what it isn't. Okay, so some of these are common sense, like 4v plus 7 is written as a sum of 3 terms. Okay, how many terms are actually here? There are 2. Okay, so that's a no. 1 and 8, are they like terms? So can I add 1 and 8 together? The answer is what? Yes, it is. Okay, 2 is a factor. Now, we haven't really talked about this, but when a 2 is on the outside of a number, it's actually a factor, okay? Because what you would be is understand that 2 is a factor of the multiplication. So if I put 1 plus 8 together, I make that 9. So if I were to solve this out, it'd be 2, and then I would go 9 like this. And then 2 times 9 is 18. What if I wanted you to go backwards? Go backwards means I would have you say, well, I want you to get to 9 by itself. Well, you would factor out or divide out a 2, and then you'd end up like this again. And so what it is it's a factor is it, do they share a number in common together? And the answer is yes. All right, 4v plus 7, 4v is a constant. Remember, the constant is supposed to be the number by itself, which would be 7, so this is a no. In 4v, 4 is a coefficient. This is a true statement. Okay, what I want you guys to understand is this is a term. And this is what's going to be called, in this case, if it's in the front of an equation, this is a coefficient. But if it's in the front, so like if I say 3x squared plus 2x plus 7, this is what's called the leading coefficient. Okay, we will be getting into that later on in the year. But understand when it says coefficient, it is the number with the term and the constant. Okay, and then the other one over here. All right, 5y plus 1 plus 2x is written as a product. Well, this isn't product, that's addition, which is the next one. It's a sum, right? 2 is a coefficient. So the question then becomes, ladies and gentlemen, is 2 a coefficient? The answer is yes, okay? It is a coefficient because of 2x right here, right? Because this actually equals 2x, and it's the coefficient right there. 2x and 1, are they like terms? No. 1 is a constant. Yes, because it is a number. All right, what I want you guys to do is look at this, study this part, and then answer these two questions. All right, so last thing is 9u is a factor. Nope, because it have to be outside the parentheses, and there's nothing outside the parentheses. 4 is a constant. Yes, it is. 9u is a term. Yes, it is a term. Remember, all of these are actual terms. 9u is a coefficient. No, 9 is, but not 9u. 3v and 5v are like terms. The answer is yes to that. And 8u plus 3. 8u is a constant. No, remember, a constant is a number. This is correct. And 8u, 8 is a coefficient. That is correct. 8u plus 3 is written as a sum of 3 terms. Well, how many terms are there? 1, 2. So that's not correct. 4 and 9 are like. Yes. 5 is a factor. Yes, it is, because it's on the outside. All right, please make sure as we go through, these last couple examples are going to be on your homework for Alex, and they are going to be a struggle if you don't understand the pieces. That's the goal. Look at the equations, understand the pieces of the puzzle as we go through this, and you will be successful. If you have any questions, come see me in class. Look through the guided work if you need anything. Otherwise, ladies and gentlemen, good luck.